Today we're going to be talking about Module 3, Lesson 9, when we get there. And your learning goal for today is to be able to add fractions by using the least common denominator. That's underlined in yellow because that's kind of like your vocabulary word for the day. Okay, we're going to talk about what that means later. But we're going to use the least common denominator to make equivalent fractions that will help us add. Before we do that, though, let's talk about the problem of the day. A was trying to subtract 3 minus 1 and 3/4. So I can see that they started from 3. Is that right so far? Yeah. They subtracted 1. Is that correct so far? Yeah. After they subtracted 1, what were they at? 2. And they subtracted 1/4, 2/4, and 3/4. So they got 1 and 3/4. Is that correct?
No.
Is this really 3/4 here? This is really 1 and how many fourths?
1/4.
1/4. Is this really 2/4? Yep.
Yeah.
And this should be 3/4. So the answer should be 1 and 1/4 instead of 3/4. So a very common mistake I saw yesterday was people writing 1/4, 2/4, and 3/4 starting from that side. Does that make sense? Okay. What about student B? What did they do? They also started at 3 over here, subtracted 1 and got to 2. So far, so good?
Yeah.
Then they did 1/4, 2/4, and 3/4. Very good. Actually, their number line is all correct, except for labeling, right? So then this would be 1/4, this would be 2/4, and this would be 3/4. Now, they're thinking, what I think is they're thinking, okay, well, the last whole number I passed was 2, so I'm going to circle 2. But really, if we're here on the number line, are we at 2 and 1/4? What are we at? 1 and 1/4. So the correct answer should be 1 and 1/4. Take a moment right now to see if you can explain what the mistake was in each of these cases. Explain by writing it out. Looking at these fractions here, we have 1/2 and 1/5. Do you guys agree that, let's look at 1/2 first. Do you guys agree that this picture right here is showing 1/2? Yeah. Okay, and here we have the fraction 1/2. Now, if we want to make equivalent fractions, what does the word equivalent mean again? Same. We want it to have the same value. So right now, half of this rectangle is colored in, yes? If I were to draw another line here, is half of the rectangle still colored in?
Yep.
Now how many equal spaces is this rectangle split into? 4. And how many are colored in?
2.
That means that 1/2 is equivalent to 2/4. Do you agree? Okay, so we can say that's equivalent to 2/4. What if I split it this way? Now how many equal spaces are there?
6.
6, and how many are colored in?
3.
So is 1/2 also equivalent to 3/6? Did I change how much of the rectangle is colored in? No, so the same value is colored in. Very good. So that's also equivalent to 3/6. What if I put 4 lines like this? Or 3 lines like that. How many spaces are there now altogether?
8.
8, and how many are colored in?
4.
So is 1/2 also equivalent to 4/8?
Yep.
What if I put 5 spaces? 2, 3, 4, like that. How many spaces are there altogether now?
10.
10. And how many are colored in? 5. Same thing. We could do the same thing with the 1/5, right? Right now, do you guys agree that 1/5 is colored in right here in the blue rectangle? If I were to split it down now, how many equal sections are there in that whole rectangle? 10. And how many are colored in? 2. And this is what we did before, right? We would draw these rectangular fraction models to rewrite equivalent fractions that have the same denominator. Originally, my denominator was 2 and 5. Were those common? Were those like or unlike denominators? But by doing this, we ended up with denominators of 10 and 10. Now are they like or unlike? Like. So if I wanted to do this math problem, 1/2 plus 1/5, I could rewrite it now as 5/10 plus 2/10. Yes? And now I could add. 5/10 plus 2/10 is 7/10. That's what we were doing before, right? We would use rectangular fraction models to help us make equivalent fractions. But today, we're going to learn how we can use something called the least common denominator to make equivalent fractions instead. So equivalent fractions means fractions that have the same value. So my first addend, the first fraction I'm thinking about is 1/2. What's a fraction that is equivalent to 1/2? Everyone? 2/4. Okay. What's another fraction that's equivalent to 1/2? 3/6. What's another fraction that's equivalent to 1/2? 4/8. Okay. What's another fraction that's equivalent to 1/2? 5/10. Is there like, could we go on and on forever?
Yeah.
Is also 10/20ths equivalent to 1/2? Yeah, okay. What about 2/3? What's a fraction that's equivalent to 2/3? Gia? 6/9. Okay, what's another fraction that's equivalent to 2/3? Kish? 8/12. Okay. What's another fraction that's equivalent to 2/3? Jonathan? 4/6. Turn and talk to your table group. How can you come up with fractions that are equivalent to 2/3? To find fractions that are equivalent to 2/3, we need to multiply 2/3 by different versions of what number? 1. How did we get from 2/3 to 6/9? Well, we had to multiply 2/3 by 3/3 because 2 times 3 is 6 and 2 times 3 is 9.
No, 3 times 3.
3 times 3 is 9. Is 3/3 1? Can we do that? How did we get from 2/3 to 8/12? We have to multiply 2/3 by 4/4, which is 1. How did we get from 2/3 to 4/6? We have to multiply 2/3 by 2 halves, or 2/2, which is a version of 1. When I multiply something by 1, does that change its value? No. If I want to add 1/2 plus 2/3, I cannot, because the denominators, the bottom numbers, are different. Is there a different version? Is there an equivalent fraction on either side that has the same denominator? Yes. I can see that 3/6, the denominator is 6. Over here, I have 4/6, where the denominator is also 6. Now I have a common denominator. Rereading what it says in blue. To add and subtract fractions, we need to rewrite the problems using equivalent fractions. Do you guys see how these are equivalent fractions that have a common denominator? Common denominator means a denominator that is the same. They have it in common. Does 3/6 and 4/6 have a common denominator? What denominator do they have in common? 6. So I can rewrite this problem now. Instead of writing 1/2, I can write 3/6. And instead of 2/3, I can write 4/6. Now, does this math problem have the same denominator?
Yeah.
Can we add?
Yes.
If I have 3/6 and I add 4 more 6, how many 6 do I have? 7/6, and which I can simplify to be 1 and 1/6. It is helpful to use the least common multiple of the denominators in order to find the least common denominator. Okay, what I mean by this is this. A multiple of a number is when you multiply it. So if we count by 2's, 2, 4, 6, 8, 10, 12, all those numbers are multiples of 2, right? And so we're going to find the least common multiple. If you don't know what that word means, LCM, you just think one word at a time. If something is the least, does it have a bigger value or smaller value?
Smallest.
So least means smallest. Common means what do we have in common, okay, of these two denominators. So the first denominator in the first fraction is 9 because we have 5/9. Yes?
Yeah.
So we're going to write out, what I want you to do is you're going to write 9 like this. And then we're going to write out all the multiples of 9. We're going to skip count by 9 and write it down. Ready? Let's do it. 9. And then what? 18. Then what? 27. Then what? 36. Okay, let's stop there. My next denominator is what number? Is what? 6. So you're going to write out a 6 like this. And the reason why we write it like this is because we want to make sure that we know which multiples we're listing out. Now let's write out the multiples of 6 by skip counting by 6. Ready? Go. 6, 12, 18, 24. Okay, let's stop there. Do we have something in common? What number is in common? 18. That means my least common denominator, the smallest number that I have in common between those two denominators, will be 18. That means then what I can do is I can use what I know to rewrite the problem using equivalent fractions. Now I know that instead of having 5/9, I want the denominator to be 18. And instead of 5/6, I want the denominator to be 18. Okay, well how did I get from 9 to 18? I had to multiply by what? 2, which means in the numerator I also need to multiply by. So that means 5/9 is equivalent to how many 18ths? 10 18ths. Okay. What about for this, to write this equivalent fraction? To go from 6 to 18, what did I have to do? Multiply by
3.
So in the numerator I have to multiply by 3. So 5/6 is equivalent to 15 18ths. Now can I rewrite the problem? Instead of 5/9, what should I write?
10
10/18. Instead of 5/6, what should I write?
15
15/18. Now do I have the same denominator in my addition problem? I have 10/18 plus 15/18. Now do I have the same denominator? Yeah. Can I add now? If I have 10/18 and I add 15 more 18ths, how many do I have? 25/18. Is that a mixed number? No, it's an improper fraction. That needs to become a mixed number. How many 18ths would it take to make a whole number? 18. Do I have at least 18 there? Yeah. So this is the same as 18/18, which is 1, plus how many would I have left? 7/18. Very good.